Good afternoon, sir. So, am I audible to you?
Am I audible?
Yes, sir. Yes. I hope you're ready, sir.
Yes. I'm ready. I'm ready. Yes.
Okay, okay. So, as soon as the participants join, we'll start the session.
Okay, no problem. No problem. Thank
Okay,
you.
okay. Thank you, sir.
Can I just taste my maybe a slide?
Yeah, yeah. You can. You can, sir. It's visible.
Okay, just let me do the. It's coming.
Yes, sir. Yes, it's coming.
Okay, so I'm stopping the share then.
Yeah, okay. After a while, we'll start.
Okay,
Exactly at 2, we will start, sir.
okay, no problem. Thank
Okay,
you.
okay, sir.
এখান থেকে কি হচ্ছে আপনার এসডিআই নিল সাইটা এসডিআই হবো সাইটা এসডিআই কে হবো যেটা আমার দুটো এসডিআই বর্তমান বলতেছে আমার
Good afternoon, everyone. I welcome you all to the fourth session on the second day of the online workshop on data analysis for academic research with art. We are privileged to have with us Dr. Himantri Burman sir from Descriptive University, who is here to deliver the session on descriptive statistics and data summaries. I welcome sir to this
Thank you.
session. So let me give your introduction to the participants. Dr. Himantri Burman sir is an assistant professor at Center for Management Studies, Descriptive University. He is doctorate in business administration from Assam University. He holds multiple postgraduate degrees, MSc in mathematics, MTech in information technology, MA in public administration, and MCom in international business. He also has postgraduate diplomas in business management as well as in operation management. Two scholars have been awarded PhD in business administration by Descriptive University under Dr. Burman till date. He has published a number of Scopus or Web of Science Index research articles along with textbooks with chapters as well as other peer-reviewed literature. Dr. Burman is currently officiating as the head Entrepreneurship Development Center, Descriptive University. He is also the assistant program coordinator, NSS Cell, Descriptive University. He is a technical expert with the Center for Technology, Innovation and Incubation, Descriptive University, and is currently mentoring 2 startups. He has 22 years of experience in teaching, research, and academic administration. I welcome you, sir, to the session, and I welcome everyone again to this fourth session of the workshop. Sir, the session is yours now. You can start the session. Over to you, sir.
Thank you for the introduction and also giving me the opportunity to maybe discuss about a contemporary concept or maybe a language that is being used now all over the world, especially because we are now in an era of data science. A lot of data is available which needs to be analyzed, and R happens to be a very important tool in that whole approach. So I was again that means I attended the morning session today, not the entire session of Singh sir. And yesterday, of course, I did not attend. So what he talked about basically is related to my topic, because visualization is part of data summary. So he has already covered one part, and because I covered, that means the topics were already listed in the brochure. So in my presentation today, I will not be handling that visualization part. Okay, I'll be totally ignoring that. And I think I listened to him. He covered at least 9 different plots in his entire lecture. He gave ample demonstrations in R using R Studio.
Yes.
So that part I will not consider. Also, this is for the participants, is that maybe some of the things I'll be talking about can be a bit of repetition, because again, you cannot help much that there will be some repetition might be. Another thing is that since there are many participants, a few participants might be knowing R sufficiently well, or they might even be experts, so as to say. There will be others who might have just started, or maybe this is their first exposure to R. So again, as part of this presentation, I have to strike a balance somewhere. So I do apologize to all participants who might feel that, okay, most these things actually are being, I'm just being provided the same information again, or which I already know. So that is part and parcel of any presentation might be. Also, I firmly actually believe that R is just a tool. So to use the tool properly, you must know about the basics of R. again, which I hope that you already have been provided with some information, even for those who had just started. Because yesterday also there was a session on R and R Studio. So I'll be also using R Studio only in the demonstrations I will be giving. But what I also firmly believe is that if you want to use a tool for a particular purpose, the background must be well known. That means you must be very clear about the topic itself, that is descriptive statistics and data summaries. So without having a thorough knowledge of maybe this topic, just using R will not that means I think it's recommended, simply because R as a tool will give you some certain kind of outputs, the outputs you get. But ultimately, you have to do the interpretation. You have to figure out that whether you are using the right tool or not. In the morning also, you are doing the visualization. You must know under what circumstances you will be using which plot. So that is why I will cover certain important aspects, or I will try to first go to some theoretical background of the topic. Again, this is a very common topic. Maybe when you talk about descriptive statistics, you have been doing it from maybe your high school. But still, there are certain other things that need to be maybe again discussed, or maybe in a way you can say that it's just a review again. That, okay, many things you already know, but again, you just need to have a refresh those things. So I'll just be starting the presentation now, and hopefully I can do justice to the fate reposed on me, and let's see how things progresses. So before I start, if any participants would like to make any comments. How it has been going on? You are comfortable with R or R Studio? Just to maybe again have a feel of the participants. Maybe you can even type it on the chat box. That's not an issue. Okay, fine. Maybe we'll not waste time. So we'll start off that. Maybe I'll just switch up my video. My connection is not that stable
Okay,
in our university,
okay.
unfortunately. Yes, I think someone is speaking.
No, just
Yeah, okay,
I'm telling, sir.
Okay. So I'll just switching up my video and I'll start the PPT. So I hope my slides are visible.
Yes, sir, it's visible.
And my voice is also clear, more or less?
Yes, sir.
Okay. Thank you. So let me know if there is any problem, either the voice or with the presentation.
Okay, sir.
So these are the topic that was explained to me, descriptive statistics and data summaries. And just before, again, I've already given talked a bit. I'll just take maybe just 2 minutes more, just talk about the place I belong to, because it is because of this place that I'm here, might be. So as already given in my introduction, I teach here at the Center for Management Studies, Descriptive University. Even though my background is not in management, because I did my MS in mathematics and then my MTech in information technology. This is the place where I've learned management, and where from where or during my course of my teaching here, I also did my PhD in business administration from Assam University. So you can say that I've learned management on the job, and maybe one reason why you are interested in data analytics or data science today is that management needs it, and that is actually management is driving the progress in data science. So somewhere R is now being used by management professionals a lot. So we are offering this program, then MBA full-time, MBA part-time, MTTM, BBA, and PhD. I teach across all the programs, and as already again said in the introduction, I have spent 22 years out here. Thank you. So now we start with the presentation. So I start basically with the first part, that what is descriptive statistics. Now, as all of you know, statistics is a science, is an offshoot of mathematics. And there are interesting things that are being said about statistics all the time. That if you want to lie also somewhere might be, you can use statistics to lie. You can hide things using statistics. So that is an extreme opinion also on statistics. But the moot point is that without statistics, maybe today it will be difficult to at least run business. So if you talk about strategy, if you talk about business decisions, statistics is very crucial all the time. And that is why maybe in any management program, you have papers on quantitative techniques. And most of these quantitative techniques are again covering statistics somewhere. Even though mathematics has to be a part, but it is statistics that plays a very important role in management. And any management professional needs to be very comfortable with statistics, at least basic statistics. Now, these descriptive statistics may be looked at from two different viewpoints. Again, you might agree to it, you might not agree to it, and that is absolutely fine, because it being an academic discourse. Not agreeing is also okay. I think we need to disagree also in many cases. Just because maybe I'm the expert sitting out here, it is not necessary that you will be agreeing to maybe what I am saying. Now, if you ask me, as I say, there are two different viewpoints. One actually is to look at it as a branch of statistics, okay, which summarizes or describes the characteristics of a data set. In fact, the other branch actually is called inferential statistics. And both these branches are interrelated. While your descriptive statistics will tell you what the data is all about, inferential statistics is used to make inferences, means talking about the future. Based on current data, you try to make some future forecast or other kind of things. That is why we say it is inferential statistics. You make inferences based on current data. Now, the other viewpoint actually is to what? Look at descriptive statistics as a collection of what? Descriptive statistic. Now, remember the S is missing here. So I'm saying it's a collection of descriptive statistic. Now, what is statistic? It's a value that has been generated from a data collection, such as a summary measure, like say mean or average, whatever you call it. So these are actually called statistic. Remember, without the S missing. In fact, those who know about statistics, I think many of you know about that. There is something called sample from a population. So for a sample, it is called a sample statistic. And for the population, it is called a population parameter. So from the sample, if you are finding the average, you are finding basically the sample statistic. And then that will be used to infer or to estimate the population average or the population parameter. And remember, all the base functions that will be available with R, they talk about the sample. Okay, they don't talk about the population. So the population, that means functions are actually different. They are not a base function basically. So base functions will talk about the sample as far as R is concerned. So that is why I'm saying that the second view of looking, or the second view of descriptive statistics is what? That it is a collection of descriptive statistics. Okay, so that gives us the term descriptive statistics. So from no S to an S in statistic, because it's a collection. Fine. Now, when you talk about descriptive statistics, there is something called outlier. And now this is some kind of a warning before we proceed. Okay, so what is an outlier basically? Again, this is a very common term when you come across analysis. Now, outliers are an aberration to a data set. That means something that is not expected. Now, these are data points that significantly differ from other observations in a data set. And this may include errors, human errors also, anomalies, Anomalies means basically they are not errors, but it happened, or rare events within the data. Now see what errors mean. Say I'm entering data for my students, say out of 100. So I'm entering, somebody got a 90, and just because I was doing it very fast, instead of 90, I enter a 900. So that is an outlier, okay, and that is a serious error because it will have an impact on maybe my average score of the students and a lot of other things. The point is that when we know that an error can happen, it's important that we take care of these errors, okay, or to so as to say that outliers. Now you might be knowing about something called data validation. Before you enter data, it is important that the data is actually checked for its correctness. We call it data validation. For example, you are filling up a form where you need to enter your phone number. So basically nowadays what it does, it will actually send you an OTP to verify that the number you're entering as your phone number is actually your phone number. It's not some random number you've entered just because you're required to enter a number. Because maybe the one or the party which is asking for your phone number, they need a real phone number, not some random phone number which does not work. Okay, so that is validation. Fine. So a lot of validation techniques are nowadays used actually. Again, in that same point, you might be seeing that when you enter these online forms, in most cases, you are actually entering data from a drop-down menu. Why? Again, to actually keep track or maybe control the data you're entering. Now, for example, you have to select your state. Now, the states will be listed. Remember that puts in more effort on the part of the designer or maybe the backend. For you also, you have to maybe just select after the drop-down comes. But that is very important to see to it that the data is correct. Why? Say I'm from Assam. Now I type Assam as ASSAM. Fine. Somebody else might not type Assam as ASSAM. They might type it as ASOM. Now you see I have the variation of the same data. Now tomorrow I am finding that how many people are from Assam from my data set, and I am putting the search term as ASSAM. Only those who entered the state as ASSAM will come in my list. Those who put it as ASAM or ASOM or AXOM will not come in my list. And that can be a real problem, okay, as far as my data is concerned. So, because data analysis comes later. So even if you're talking about data analysis, we cannot ignore the data entry part, from where we are getting the data. And as I say, specifically important are the outliers. So detecting and managing outliers is important in descriptive statistics to ensure accurate and reliable data analysis. So it's also maybe a standard thing to tell to you that before you do the analysis, check your data properly. Okay, see to it that it is correct, or otherwise, what is going to happen that in computers we use a term called GIGO, GIGO. So GIGO means what? Garbage in, garbage out. So if your data has a lot of garbage, including outliers, so that your output also will have a lot of garbage. So and your entire analysis will come to nothing. So you should be careful about that. So next is the second term or in my topic, that is data summary. The question is, maybe for a layman, they might say that, okay, these are same. And in a way, there is no harm if you tell that data, that means summaries and descriptive statistics are similar. But since we are learning it, maybe as some kind of training or something, we are not a layman now. And so we need to look at it more deeply. And if you look at it deeply, there is some difference. So descriptive statistics is about the measure or method to summarize data, and data summaries are the actual output. So when you talk about data, that means descriptive statistics, you are talking about the methods, like say your average, your mode, your other things. And the output you get, that is actually a summary. So it's the method data summaries are the output. So descriptive statistics can say are the methods and data summaries are the output. So you use the descriptive statistics to get hold of your data summaries. Now this is one example I'm giving because now this cricket is being played. So finding the average run scored by a batsman in a test series will come under descriptive statistics, while presenting the average run scored by all the batsmen in a team using a table will be a data summary. Okay, I think that clearly explains the difference between your descriptive statistics and data summaries. Now, data summaries can either be quantitative or visual. The example I gave was quantitative. If the same thing I create a graph, whether it's a bar chart or a column chart or anything else, that will be visual. And nowadays, visual is used a lot. Especially, you might have come across the term called dashboards. So dashboards will use this visual data summaries a lot because again, it's a very nature that because it's visual, it's more appealing. You can understand more things. You can manipulate those charts easily. So a lot of things are there. And nowadays, collection of summarization techniques is discussed under the heading of exploratory data analysis. So again, many of you might have heard this term, but if you have not heard it, maybe you now use this term a lot, exploratory data analysis. So you're trying to explore the data, and basically these are all collection of summarization statistical techniques. Now again, when you talk about analysis, because ultimately data summary is also a data, it also comes under data analysis, right? So we must again be clear about these three things. One is what? Multivariate, bivariate, and univariate. I'm this order. So what is univariate? If it describes or you are working with only a single variable. So again, in analysis, this concept of variable is very common. So if you are using a single variable, that is univariate. And most of the things I'll be discussing today will talk about what? Univariate. Then if you are talking about relationships or you are talking about two variables, you get a bivariate. And multivariate is a more generic term which talks about two or more variables. So from that angle, bivariate analysis is also multivariate analysis. So I think I had gone through again this brochure. So there is also one session on multivariate analysis. So there it will be discussed more. Now we have tried maybe got a background on both. And again, before discussing further on any topic, maybe why it should be discussed also becomes important. Remember, maybe many of these things are known, but still, just for the sake of completing the discussion, this has to be talked about. That what is the importance of descriptive statistics and data summaries? Or for that matter, if you put in another way, why is this particular topic put in your this particular 5-day program? Now, the point is that it gives a snapshot of the data. So you understand what's a snapshot. So you have a large data set, I get a snapshot. Now, this is especially true for a large data set. For example, for a batsman who has batted in 200 test innings, the score made in each of the 200 innings is overwhelming. So someone just rattles out all the 200 scores one by one. So what will you do with that? Maybe you just listen to it. And at some point of time, you'll say, okay, enough. It is enough. I do not need to know all those. But the summaries like average score, number of 50s, hundreds, strike rate, immediately tells us about the quality or success of the batsman. So that is why when a batsman comes into the crease or a bowler comes to bowl, they will provide in your screen what? This summary statistics, okay, or summaries, data summaries, because that is sufficient for us to know that how the batsman is he capable or how experienced he is, all those things. So giving his score one by one, maybe it might be of interest to some statistician, not to us. We had already talked about outliers. So descriptive statistics will also help us in detecting outliers. we had said about inferential statistics, that descriptive statistics actually is the base for making inferences or going ahead with inferential statistics, and also making a lot of generalizations. And most importantly, from a management point of view, or for a business professional, now when you are making a report, it will contain what? It will contain most of the time summaries. Okay, so it helps us to communicate findings in a convenient and understandable manner. That is why I talked about somewhere a dashboard. So dashboard helps us to communicate things very easily to even to layman's. Now, coming to the main categories of summarizing data. Okay, so again, these are very common terms. You keep on hearing them all the time. Now, these are measures of central tendency, the mean, the median, the mode. Then you have the measures of dispersion. We also call them variability, like range, quartiles. You can find the variance, standard deviation, coefficient of variation. Now you see again that this variation and standard deviation are interrelated, because standard deviation is the square root of the variance. But anyway, these two are considered as two separate measures. And then you have also measures of frequency, like your count, proportion. Okay, so these are measures of frequency. Now we'll come to the main discussion, that is how whatever I've discussed till now, R helps us. Okay. Now again, I have no idea, that means that how many are already into R programming, or for that matter, if you have done any kind of programming in maybe any language. So again, maybe I'll just put up a question out here. Anyone out here in the list of participants who has no introduction or maybe no experience with any kind of programming? Anyone out here who has done no programming? Because ultimately, you see, R is a programming language. So anybody who has done no programming? Anybody out here in the participants? Okay, at least one participant has put in the chat box that now I've got two. Fine. So maybe my assumption is a bit clear that out here many, so it has now come to 4, 5, 6, 7, maybe, yes. So many are not accustomed, or maybe you have not been introduced to programming. So that is why maybe you see, actually there is no point talking about a lot of things if the basics actually, the familiarity with the basics are not there. And maybe this is a good thing, because the other topics are quite advanced. I think this is one of the most fun topic, the one I'm handling. It's a very introductory topic in context of this program. So it's not bad that I give you some more introduction actually on maybe programming also, and how you move about in R. Now you see, as I said, R is a programming language. Means what? R is used for coding. Coding means ultimately you will like to write programs. Now, why you have a program for? For example, you are using Excel or using SPSS. Now they are applications. So the code is already there. You enter the data, the processing will be done by that application, and you'll get the output. But R is not like that. In R, you have to do the coding on your own. But the good thing about R is what? That R is easy to learn, simply because the complications of other programming languages you will not see in R. What does it mean? It means that many of the things will be straightforward. Like, for example, you want to print something in R, it is as easy as just maybe I'll show it to you, maybe one or two. It's very simple. But the same thing, if you have to do in a programming language like C or C++ or something like that, it is a task in itself. That to print something, it is also a task in itself. So that is one part. And the other thing is what? That there are now extensive libraries in R. Means for most tasks, you need not write the code. You just refer to the code that is already written. Means somebody has written it already, it is available, you just use it for your analysis. Okay, so libraries are very rich in R. This is the same also for language like Python. Okay, so that is why increasingly people all are moving into R and Python. That means you do not, it's something like this. I want to make a car. I will not think about making a wheel, making a engine or something like that. These are all available. I just collect them, assemble them, and I make my own car. So that is the advantage of the language R, okay, or R programming, that it is easy in comparison to a lot of programming languages which were there earlier or which are already there, and it has a very rich set of libraries. So these libraries you can also understand in the sense of maybe the functions which you use in, say for example, Excel. Okay, there are a lot of functions available. That is actually what makes Excel very powerful. That you enter a data, use some function, and it will give you some output after analyzing. It becomes easy. So similarly is the thing with R. Now, when you talk about data analysis, like in a computer program, it is about what? Input, processing, output. So before processing, as I had already told you, the input, where will be the data? So in the morning session also I had seen that sir had done what? That he had actually loaded a Excel file. So where is the data? The data is in a Excel file. Fine. So loading a file containing data for a beginner is more advanced. Okay. So you do not need actually a file containing data to start R programming or to analyze data, or to not analyze data, I would say, to learn how to analyze data. Okay, because you have to learn with small data sets. With large data sets, if you go for very advanced things, especially for beginners, you'll just be put off. Okay, it is so complicated. It is something like this. Okay, so that is important. Now you see, look at this section called data structures. Now, data structures are basically what? It's a concept which you use in programming languages, which will contain data. To simply put it, it is like a box which will have data in it. That is what is the data structure. Okay. Now, if you talk about R, the various data structures that are supported. Now, again, you see, this is the advantage with R. If you talk about a programming language like C, you have to create your own structure. Things are not available. Like say, for example, out here in this slide, you are seeing something called a matrix. Now you can directly create a matrix here, but out there it is a bit difficult or maybe more laid out in some language like C, because it does not support it by default. Anyway, so these are some of the data structures which you'll be using in our data analysis, like vectors. So vectors, and the remaining thing that is written or that is displayed in yellow, that is the coding part. That will come later. Okay. Then you have something called list. Now, what is the difference between vectors and list? If you again look at the yellow portion, that if it is a vector, it is the same kind of data. You say, for example, all strings, or we call them as, you can also say text data, Ganga, Yamuna, Brahmaputra. But if you look at the list, what you say, it's a combination of numeric data as well as text data. So it becomes a list. Now, matrices, you understand what is a matrix? Matrix is a two-dimensional array. So you also have one-dimensional array, you have also multi-dimensional array. Now the question you might ask is that you already have a matrix data structure. Why you again need a multi-dimensional array? So we'll see it how multi-dimensional array is more generic. Okay, so using multi-dimensional array, you can also create matrices, but it has actually more features, so as to say, you can tell it. And finally, what? Data frames. In the morning session, basically, you were working with what? Data frames. So this data frame, if you look at again the yellow part, what you are seeing, that it has vectors, okay, and it has also, basically it has vectors only, others are not there, it does not have a list. But ultimately, you can also say that the data frame has become like a list only. So the the analysis or maybe more advanced analysis will be done on a data frame. So it is like this. So I'm now just referring to the morning session again, where sir actually loaded an Excel file that was a table, okay, which had some columns, some headings, and that is a table. So that is actually a data frame. Okay, so here also the exam, that is yellow portion, if you're seeing, so this is a table which has 3 columns. What are those columns? Training, pulse, and duration. Okay, so 3 columns are there, and maybe this is just some information where it says that if the training is heavy, your pulse rate will be 150, or that means and you have to do it for a duration of 60 minutes because you are a heavy trainer, something like that. So I have just made a simple, you have a simple table in front of you with 3 rows and 3 columns. So that is a data frame. And as I said, in the morning session, actually, you are using data frame to create those plots. Okay. Till now, any question again? I think we have discussed for another around 30 odd minutes. So anything, anyone has any question? Because I do not want it to be one way totally like this, maybe. Any questions you have? Again, you can put in the chat box, or maybe you can just unmute yourself and maybe would like to say something. Okay, thank you that you have understood. At least one has mentioned that you have understood till now. Okay. Any other response? That is it clear till now that what we're trying to do? I'm trying to build up actually where we can start doing the analysis, because this background is actually important. Okay. Okay, fine. So if there are no questions or nothing, we'll move. Right. So I will just now take a break on this presentation and go back to what the initial things we have done till now. We'll go back to R and try out these things. Okay. So if you are on in front of a machine where R is already installed, maybe you can follow with me to get the results. Okay. Anybody or maybe you have a machine in front of you, the participants, where you can maybe follow me, because then it will be more effective, I think. Okay, I think at least one response I've got, you have it. So okay, from your name, from your, that means that I do not know actually your name. Anyway, whoever said, and yes, you are familiar with R programming. Here it is written simply me. Okay, you are okay. You know, so maybe that is I expected that one. So you know about R, so you are already R. Anyone who has maybe not done R before, but you have got it installed, it is running in front of you. Anyone out here? Any participant who has not done R before, but has now installed it and now ready to jump into it? No one? Okay. At least those who have not done R previously, you might have done programming again, but maybe not done R. Those who have never done programming, because many of you told that you have not done programming before. So this is a suggestion that you try to get R installed. Okay, this is you can easily download. I think this has already been shown to you yesterday, and whatever is done, maybe you can try doing it from the resource person. Whatever say, you can try to do it, because then you'll be able to follow I think more precisely. Okay, anyway, so let me take a break from the presentation and I'll move to so this is my R's I'm sharing. So my R Studio console is visible, more or less. The fonts visible. You can just look at it more or less, or I can increase the font. Okay, fine. Since it is yes, at least I got 1 yes. So I assume that it is visible. So now you know that R and R Studio are different. So R Studio is actually what we call is an IDE, a development environment. And this is the most popular IDE for the R language. So to learn R, you do not need R Studio. You can directly do it on the R console also. That means from the command prompt. But I think everybody will advise you that you should be using, or if you use a IDE, it is much better because then you can see the output or maybe all other things also you can see clearly. It is much better. And this is the latest version I'm using. Downloaded just yesterday, maybe for this presentation today. And remember that maybe I'll be doing a few things. You might be thinking what he's doing. So maybe most of these things can be on purpose. Just because you see an error, don't get terrified that sir is making a mistake or what he's doing. There are so many errors. No, maybe that will also be on some purpose. Okay. So because we talked about variables, okay, or data structures, we need to talk about variables. So variables is like a store. Because when you do programming, you'll be doing the processing. The data has to be stored in the computer's memory. So how does the language refer to that memory? Through a name of a variable. So I will reserve some memory with a name. Okay. So that space basically is the storehouse. Okay. And it is called a variable because that storehouse can contain different data. Okay. And there is also a concept of data types. So I showed to you, those are different data types, numeric, text. So a variable will have two things. One is a name, the other is the data type. Now in R, variable declaration is not necessary. You need not declare variables. Okay. You can directly use the variable. Even a type did not be declared. But R knows what kind of data it has. Okay. So if I declare a variable, say, or write a variable like say X, because that is common, and X has the value say 5. Okay, X has the value 5. Now this one actually basically this arrow mark. Okay, you can say the left arrow mark. Fine, that is called an assignment. Remember, R will also support equal to, but this is not preferred because most programming languages will take an equal. So they will write X equal to 5. But here we'll say X arrow 5. Fine. So if I press an enter and nothing comes out, means whatever instruction has been given. So this is, I'm giving instructions. So it has accepted. So if there is some problem with the instruction, it will give me an error. So something, it will give an output. Okay. So what I've done here, I've just associated the value 5 with the variable X. And because 5 actually is an integer, so it will have that, you can say it's an integer variable. Now, if I want to know what does X really contain 5, I just type X and press enter, and you see it displays that the value of X is what? 5. It is as simple as that. R also supports this print function. So I can write print and within it, I can type the variable print X. Now print is a function. So we'll be using now in the morning also, you are using a lot of functions. So here also I'm using a function called print. What it says that, okay, print whatever is there in X. So if I press enter, it gives you the same output. Okay. So very basic. Okay. Variables and how you know what is there in the variable. So either you can directly just type the variable, press enter, or you can use print, and within those braces put the variable and press enter, and it will list you out. Okay. Now we had in that presentation, we had talked about those data structures. Okay. The first one was what? Vectors. Okay. The first one was vectors. And we had named the variable as something like reverse. So instead of X, I'm saying reverse. Again, you are advised or it is suggested that when you give variable names or these names, give relevant file names. It is easier than later on. Okay, so I could have also written X, but since I will be it will be containing the names of some rivers, giving an appropriate name or is much better later on. Okay, it will help us to keep track better. Okay, so rivers, and then we used again maybe a keyword, or you can say it is again like a function. There was something called C. Okay, and within that we listed the name of the rivers, and because it is text, you have to type within single quote or double quote. I'm using double quote. You can also use single quote. So sorry, I didn't type rivers. So it was like say Ganga. Okay, then I give a comma. This is the second river. Okay, say Brahmaputra. Okay, now say Yamuna, like this. Fine. I can keep on adding as many as I want. Fine. And what did I tell you? That I press and enter. If it displays nothing, everything is okay. And if it displays something, there is some error. Okay. Now you see, there is no display, means everything is correct. Now what I again will suggest you is that you can intentionally, because if you have understood the correct syntax, so this is the correct syntax, you have understood. Willingly or intentionally, you try to make some mistakes. Okay, so let me, for example, not give a comma here. Okay, does it take? Okay, before that, what I do is, before that, let us display, because this we have already learned. So I'll just type reverse. Okay, and you see it lists the contents of that variable or that structure, name reverse. Fine. So I could have also used what? Print reverse. Okay, and you see it takes. Right. Now here you can make some mistake. For example, because as you have seen that when I am using the variable, all those things I am putting within double quote. So you can somehow make a mistake that instead of, well, while printing, you are putting this reverse under double quote. Okay, and see, it is not giving you, it is not showing you any error, but it is not giving you the contents of that structure. I hope you are seeing the problem, because it just prints whatever is given to it. So it takes that as an input, that reverse word itself as the input, not the variable. Okay, so especially for beginners, this can be a problem. Okay, you can just maybe forget or maybe make this error, and you will not know that it is an error because it is giving you some output, but not the correct output. So be very careful that with the print, or as you will see later on, that when you are using the functions, the structure should not be used within quote. Otherwise, that will be itself taken as the input. Okay, fine. So now, as I said, I say again, I'm making an error intentionally. So just to see if something happens, say I do not give this comma. So Ganga, comma, Brahmaputra, and at the end, there is no comma. Now you see it is giving an error. This is how an error will look like. And you see what is written there in the error message. Unexpected string constant in reverse. Okay, so there is some constant, it is getting something, right? So remember, if you just see this error message, it can be difficult for you to understand what the error message is all about. But you make an intentionally error and see at the error message. Okay, you will know what this error now points to, because I made the error intentionally. It shows an error message, and whenever now I see this error message, I know what error I had committed. Okay, and this is especially true for beginners. Remember, those who are just starting, this is very important for you. So I will correct it. So this was my original one. So I reassign the contents to the structure reverse. Okay, so it is done. Similarly, the next one was what? About a list. Okay, so I'm giving the name as my list. Okay, this is the same thing. And here, instead of using a C, I have to use what? List. L-I-S-T. Okay, and say I am writing Ganga, Brahmaputra, and say Ganga is 2900 kilometers long and Brahmaputra is say 2500 kilometers long. Okay, so this is a list now. Okay, so it is again correct. Fine. And let us now get the output. So I can type what? My list. Now you see when I am not, because when I created my structure, M is capital, L is small, means R is somewhere case sensitive. So even I am typing it in all lowercase, I have to use this what? This upper, that means M uppercase, L uppercase. Fine. And you see it lists. This is now how it will list. There are 4 records. 1, Ganga, 2, Brahmaputra, 3, 2900, 4, 2500. See how the output now will be showed differently. So in a reverse value, that maybe if I'm just taking an MCQ, I show you this output and I can ask you, okay, which data structure am I using? So it is not a, that means vector, it is a list. Okay, looking at the output itself, you will know that it is a list. Okay, that is what I'm trying to tell. Here again, a common mistake we can do, okay, especially in creating the vector. So let me come back to this one, this command. So again, many of us have that maybe habit or whatever you can say, that we are typing something, the first letter is a capital. Okay, in fact, when you are because ultimately coding is like typing only. Many people have this habit that they type one sentence or whatever, even word they will type, they will put a full stop. So here, if you put anything like that, it will give an error. Okay, because it violates the syntax of the language. So it has to be done exactly the way the language actually has been designed. Now you see what I've done. This L, maybe by mistake, because I have a habit now that when I'm typing a word, I make it capital. Remember, these are not problems, for example, you are doing in Excel, because Microsoft products are not case sensitive. But here, let us see what happens. It works or it does not work. Now you see there's a problem. What the problem it shows? It says that could not find function list. Now you can again get terrified. No, I list to assert. There is list. How am I not finding it? But the problem is, even looking at the error message, you will not be able to figure out that what is the problem. The problem is L should have been lowercase out here. It has to be, because the function, that because it's a library function, it is small l, not capital L. So be very careful about all these small nitty-gritties. It will, otherwise what will happen is that, first of all, you'll not be able to figure out. And I repeat that, especially for beginners, if initially you get lot of errors, lot of these things, your interest will go down. Okay, so it is very essential that you are maybe getting what you are expecting and you get excited. Okay, errors can reduce your basically excitement. Okay, so this is again I am talking from my experience, because you teach and this is what we see, that initially if they are not getting results, okay, they are not interested anyway. So if I now change it, it now is okay. Okay, so these are some of the things. Then maybe we talked about how to create a matrix, as you know. So again, I'm making it as my matrix. Okay, so my matrix, again the same thing here. This time the keyword is what? Matrix, or you can say the function is matrix. So within that matrix, I have to use a vector. So I will use C. Okay, and say write 1, 2, 3, 4. Okay, So from this, what you again see that a function can be used within another function. So that is now you can say that creating a matrix is more complicated than creating a vector or creating a list. Okay, because you have to use a function within a function. So I am using this C function within this metric function. Now, as you know that a matrix is a two-dimensional structure, so you have to also specify what? The number of rows and number of columns. Okay, so this is specified using n rows. Say I'm taking 2 rows and 2 columns. So n rows equal to 2, n columns equal to, or number of columns equal to 2. You could have also given it as maybe number of rows equal to 4, number of columns equal to 1, or 1, 4. So these are the different options that are available. And now you see basically this matrix function has 3 inputs, or these are also called parameters. First is the data set, which is a vector, and then the number of rows, and then the number of columns. Okay, and let us press enter. So again, it is giving me some error. Maybe what do you think? So it is what it is saying. Unused arguments. Fine. So I have made an error here. Okay, it is an error. So what I have to do now? Correct the error. So I have understood what I have done. So it is saying something about n rows and n calls. So the error is somewhere out there. So in fact, it should have been n row and n call, not this s is not required. Okay, so remember, because I'm used to it, looking at an error, maybe I can quickly figure it out. So you should be careful. Now you see this time there is no error. And now let us type it. So I can get the contents in 2 ways. One is just directly type what? That means this structure or a variable. So if I type it, you see this is your output 1, 2, 3, 4. Fine. So it is printing in what way? Columnar way. So this also you can change. You can make it 1, 2, 3, 4 also. So we'll not go into all those things right now. And if you look at the label, so it means that it is saying that comma 1 means this is the column and this is the row. So in the row headings, you can see that it is 1 comma 2 comma. Here it is comma 1 comma 2. So that is how R deals with matrix. That means the representation part. Okay, fine. Is it clear till now? Again, if you just give something on the chat box or opening your microphone that you have understood till now. Whatever was there in the slide, you are now trying to do it practically on R Studio. Things are okay? Okay. So I'd be, that means I'll appreciate if I get some feedback from those who are new, even from those who are maybe quite experienced, that you're seeing things clearly, understanding things clearly. So that also keeps you engaged with the entire deliberations. Okay. So online maybe programs has limitations instead of its many advantages, but there's limitation you need to take care. So that because we must be able to deliberate effectively as far as possible, and maybe just your response here and there will keep both of us engaged, you as well as me, so that I know that you're at least following what I'm trying to say. Okay, fine. So we have already talked about metrics. So now you have seen that my screen, my console, so as to say, is getting cluttered. Now this R Studio itself also has a lot of commands. These are not now R commands. Okay, these are R Studio commands. And I can clear up my console using Control L. Okay, Control plus L. So basically you will use this one, Control plus L in the keyboard to clear up your console. So clearing your console does not mean that whatever variables you have declared or the structures you have declared, they have vanished. They have not vanished. They are there. Only thing is that where I'm typing my commands, that is now cleared up. Okay, fine, just for my convenience. Fine. So you use Control plus L to clear up the console. So the next one we had talked about was what? One-dimensional array. Okay. So let me use the variable as 1D array like this. Okay, and I will create my 1D array. Okay. Now say again I will use the C function only. Now say I am writing 1, 18. So again, if I just ask you a question, you know what is an array? Array is a collection of values. So my array which I've created 1D array, how many values it has? How many values the R has? That means this 1D array has. Again, you can type in the chat box. I'm typing C1, 18. I'm creating an array called 1D array. So as you know, array is a set of that means values. So this one, how many values 1D array has? You can type in the chat box also. Is the question clear? Array is a collection of these values. So if I'm typing the structure, the name is 1D array, and I type C1, 18, this 1D array, now if that means if I display this 1D array, how many values will be listed? Okay, at least one response I've got. 2. Okay, that is what it is. You will get 2. So let us display it. So I'll just type 1D array and it will give me 2. Now the same thing, but say I wanted that it should have 18 values. From 1 to 18. You need to make a small change. Okay, instead of 1, 18, what will you give? You will give the column. Okay, so if I write now 1 colon 18, 1D array now has 18 values starting from 1 and going up till 18. Now you see again I print it and you see now it has listed 18 values 1, 2, 3, 4, 5, 6, 7, 8 up till 18. So my array now has 18 values. But say if you want different values, you have to put them separately. Say 1, 5, like this. So like that. Next is a multi-dimension array. Okay. So let me name it as multi-array. Okay. So here you have to use the function array. And within array, you have to use what? A one-dimensional array, that means. So I can directly type that C1 colon 18, or I can also type 1D array because this is already created. This is already created. So I will create my multi-dimensional array using the already created array. Okay, that means the 1D array I had created. And I also have to specify the dimension. Now what these dimensions mean, you see. So I'll write dim equal to C, say 3, 3, 2. Fine. So what does it mean? It means that out of those 18 values, I'll be creating two 3 by 3 arrays. Okay, so I create this one. Okay, 1D array, no. Okay, let me. Okay, again, as I said, it should have been capital O, right? Because I had given capital O, not small o. That is the error it showed. 1D array. Okay, it was 1D array. So I had made the mistake in referring to that one. So, okay. So I create this one, now this is created, and now I display it. Okay, so this is, you see, I created two 3 by 3 matrix or two-dimensional arrays of dimension 3 by 3. So this is why it is different from your matrix structure. Okay, so this multi-dimensional array is different from your structure. And finally, we come to what? This data frame. Okay, now let me create this my data frame. Okay, what was there in that slide? So here you'll use the function called data.frame. Okay, so when you type it again, this is a good thing with now today's IDs that you type something, it will show you. So I have to use this data frame function. And now, as I said, a frame is a table. So table has what? It has some columns, and a column has a heading. So what are the headings I had used? I had used something called training. Okay. So what was training looking like? So it was training. There are 3 types of training. So it is a vector consisting of what? Heavy, then moderate, and then you had what? Light. So I have 3 types of training. Then I had used something like pulse. Pulse is also a vector. Okay, so pulse is also a vector. So it is also a vector of, say, the values, say 150, 120, 80. Okay, and finally I have something called duration. Okay, so duration of again was a vector, and I had given some, say, in terms of minutes, say, or hours, you can say, or maybe let us give me minutes, say 120 minutes, 90 minutes, and say 30 minutes. Okay, so I have created my data frame, that is my table. Okay, so it has been created, and now I type my data frame. So this is the one I had created, and you see, right, it is showing. Fine, it is showing that one. Okay. Okay, I just made a small mistake out here. So I should have given a okay, fine. So first is the list, that means data, and now you see this is the table. Okay, so this is the table, this is the table, and this is the data. Okay, this is the table, and this is the data, right? Anyway, so we have looked at how you work with your factors, okay, or the data structures. So we now again go back to now the actual part. 1 hour I have spent. Now the other year, the actual, now this, how you start doing this summary. Okay, what are the things you will do. So I will again then go back to my presentation. So we have already looked at this part. Okay, if you remember, we have already looked at this part, and now you see the functions that are there in R. Remember, these are the base functions. So what I can do, I can find a summary. I can do what? I can find mean, median, standard deviation, variance, minimum, maximum, range, quantile. All these things I can find through inbuilt functions. So basically, when you use a summary, it will show you all these things. Okay, it will show you all this: mean, median, standard deviation, variance, minimum, maximum. Most of these things it will show you. So let us again remember what I told you in the beginning, that you must have a clear idea about this methods. What is mean? When you use a mean? When is mean appropriate? How do you make your conclusions about the mean? So the theoretical background is very important, because R will give you calculate something and give you some output if there is no error. But if you do not know about the methods properly, you will be failing in making the right interpretations. Okay, so again, this is a suggestion that you should know about all these things deeply if you are using them. Of course, these are very basic, but in spite of them being very basic, many a times we are just not, maybe we have not got into in depth. Okay, but I would again advise you for that. So I'm again going back to my R Studio. Okay, so I think this R Studio is again visible now. Fine. So summary will be used, we can use on a that means a vector. Okay, so for example, we had let me create another variable, a small data set, say X. Okay, so X has some data, say 12, 20, 30, 40, 50, 70, 100. Okay, so I'm working on this data. So I've created a vector called X, which has 1, 2, 3, 4, 5, 6, 7. So if I now write summary of X, you see, this is what, oh sorry, I again made a mistake. It is SUAAMARY. Now you see, it is giving you the summary results. Minimum is 12. Okay, maximum is 100. Then your first quartile is that 25 percentile, right? 25. Then is 25, median is that 50 percentile, third quartile is 75, and your mean. So if you now go back to this slide, what you have seen in this summary, you have seen the median, mean, you have seen the median, you have seen two quantiles, and you have seen the mean and max. Okay, so the others you are not seeing. Is this clear? This first data summary function, or in R summary? Remember, it's very simple for that means to start with. So you just create a data set. I created the data set called X, where it has some data. There's just some numerical data, and you just use the summary function on that data, and it will give you the output, some summarized values. So now let us see again one problem. What can happen? So I go back to R Studio. Now say this time I had created that data set called reverse. If you remember, we had just created, remember, I had created this data set called reverse. Okay, Ganga, Brahmaputra, Yamuna, it is still there. So if I use the summary function on reverse, see what happens. Now you see the output now. It is giving you certain information, but this is not what you are expecting. Okay, this is not what you are expecting. That means basically this length, it tells us that there are three factors or three different reverse nodes. So these are considered as factors. Okay, so that is what it is saying, that there are length is 3. But say the output I was looking at, it was it should have count something, it should have been like this, that because for now this factors, it cannot give you, we give you max, mean, median, all these things it cannot give. What it has to give you? It can give you a count value, count. So this means summary, if it works properly on this river, it should give me what? Brahmaputra 1, that means occurrence 1, Ganga 1, Yamuna 1. Okay? but it is unable to do it directly. That means we have to first do an intermediate processing with this kind of data. Now, this is where things will become a bit more complicated, that you cannot directly use a function. You have to do some intermediate processing. Okay. So what we can do is that from this reverse, let me create another variable called reverse one. And this one, I'll get it by what? First processing the reverse using a function called, say, factor. That means, okay, factor what? Reverse. Okay, so it has worked. Now let me use summary reverse 1. Now you see it is coming. Brahmaputra 1, Ganga 1, Yamuna 1. Okay. So basically what this function is doing, reverse 1, that means factor reverse. We are saying that the structure reverse actually has factors. That means some classes. Okay. That means these are some, you can also say these are labels. And we have created a new structure out of that called reverse one. And now it is showing me correctly. Now there are other ways of also doing the same thing. We'll not go into all those right now. So you have seen the summary. Now again, if you go back to your slide, what you see that there were some individual functions, right? Like this one, mean, median, standard deviation, variance. So when you use summary, you can see some of this, but not all. So what we'll do is that we'll use them one by one. Okay. So let us again come back to our studio. So we want to use, okay, you see mean of X is 46. Right? You see in summary also the mean it showed as 46. Okay, let me clean, that means clear up this screen again. So let me first write summary. Okay, this is a summary, then I use mean. Okay, so it is, so similarly I can find what? The median. And you see the moment I start typing, it will show me the function or name, median. So median of what? Say X again. So same 40. Mean, it will show me, okay, mean I've already done. Then I need what? Mean. Mean of X, 12, max of X, 100, right? And the others now, say you want to find the variance of X. Okay, it is showing as what? 938.6667. And the standard deviation will be what? SD. It is what? 30.63767. Now I have told you that variance actually is the square of standard deviation. As you know, our standard deviation is the square root of variance. So what I can do, from standard deviation, I can calculate, I can check whether a variance is showing correctly or not. So I can just use a formula. So I know that variance is the square of standard deviation. So what will I do? I can just write as the X, and you use this operator. This is the cap operator, cap. Okay, this is the cap operator, and you write 2. So basically what I am typing that square the standard deviation, because I want to get the variance from standard deviation. See whether it works or not. You see, you are getting the same result. Okay. So your R, it will also take these operators. Fine. Now reverse, say I want to calculate the standard deviation from the variance. So someone gives you the standard deviation, that means variance, and says calculate the standard deviation. So basically you will find the square root of the variance and you want to use R. So you will use the function square root, SQRT. Okay, SQRT of what? Variance of X. Okay, and you see you get the same result, 30.6376. Okay, so the summary will give you summary of certain things. Descriptive, that means you see basically these are descriptive statistics. It says you something, but you can also find them individually, or you can find more using some inbuilt functions. Okay, you can use using some inbuilt functions. You can do that. So let us again look at some more. Okay, so remember how you use the quantile now. You have to use those who are having, or you are working with your R Studio. Try to calculate this quantile. How will you do that? Just maybe in 1 minute I'm giving you. It is already shown here, right? It is already shown here. Quantile, this vector, instead of vector, what will you write? You will write that X. And you have to give the probabilities. So first quartile is at 25 percentile and second quartile is your, third quartile is your 0.75. That is why you are giving the probabilities as 0.25 and 0.75. Okay, so you will type what? Quantile bracket X, small x, and probs equal to C 0.25, 0.75. If anybody has done it, you can type or you can check out the result yourself, whether, because it is showing the summary, you can check it out. So let us do it. Okay, so what we are going to find? We are going to find the quantile. Quantile of what? That vector is X. And we have to give the probabilities. Probs of what? 0. You see 25 percentile and you see the first quartile 25 and third quartile is 60. Again, is it clear? So though, if anybody has done it, or could you do it? Or have you understood what you have done using this quantile? Because the others are quite simple, this quantile. Now, if I ask you, say I want to find the median using quantile, how will I do that? You can just type it in maybe you can just do it in your R Studio console and paste it on the chat box if anybody has done it or can do it. So the question is, I want to find the median now using this quantile. How will I do that? That means find the median. Just 1 minute I'm taking. If anybody wants to give the code. I hope you could get that. You see, so the quantile is a very, you can find any percentile using this quantile function, whatever. First percentile, second, tenth. Okay, so the quantile is a generic function you have, and you have also specific you can also find directly the median. That median function is also there. So this is how you can find the median using the quantile function. Okay, right. So we have seen at some very basic summary functions, or maybe some data summary, how you can do some very basic data summary. So, but here what we are looking at, we are entering the data here itself, creating our variables and working on them, which is again not the case generally. You will have a file where the data will be there. Okay, so what we have done in the morning. So in the morning you had already been shown, if I remember correctly, that the data was in an Excel file. So for that you need some other package. Okay, you need some package, additional package, and using that you can upload, that means load an Excel file. But again, for beginners, it is very important that Excel file is okay, but R, or basically many statistical software, they are not good at interpreting that Excel format. Sometimes they can make mistakes. So for them, basically always the best is either a text file or a CSV file, comma separated value file. Okay. So I will now show you how you can create. If you already know it, fine. If you do not, we'll just see how you can create a that means text file or a comma separated value file from your standard Excel file. It is just about saving it in a particular format. So again, I am taking you to a standard folder I had created here. Okay, so you see I have this standard folder, so I have some test data. So I'm opening this test data for you. I think I have to again share it. Okay, so you see this is my, so let me zoom it a bit. So this is some test data I have. We have the age, gender, height, and weight. So what I'm to do, or what I want, that I want to analyze this data now, make some summarize, or use some descriptive statistics on this data set. And what I'm going to do, that I have to first load this data. That means load this file. And I want to work as a text file or as a CSV file. So if I am working as a text file, you see what I will do. I will first convert it to what? Text file. How is it done? You go to file, you go to save as. Okay, I'll go to my folder. Again, I don't know whether it is it showing now that save as dialog box? Can you see the save as dialog box? No.
Yes, sir.
You can see it?
Yes, sir.
Okay. So you see out there, you have some options here. A lot of different options are there in Excel. And you see, if you want to save the text, go to this text MS-DOS. So if you have someone is using this Macintosh, you have to select that Macintosh. So select this text MS-DOS. Okay. I'd already saved it before, but I will just replace it again. So it will ask me, what do you want to replace it? Fine, I will just say yes. Fine. So I have saved it now. And now you see that in my folder, this text files come. This, you see this text file, text document. So if I open it, it will open in a notepad. Again, I'm showing it to you. Okay. You see the data looks like this now. Is it visible?
Yes, sir.
Okay. You see the same data. What you had seen in Excel, the same data. I have now converted to a text format. Okay. Right. Now coming back to again the presentation. Okay, you see the loading data files. Okay, so R allows all these things. And now you see what is the format or what is the code you have to write. Basically, this is that variable. Then you have to write what? Read table. Okay, read dot table. Then you have to give the file name, including the path. Okay, and there are two options. One called header equal to true. Anybody can tell me what it is, what it means? Header equal to true. When will header will be equal to false? If you have an option called header equal to true, when will header will be false? You see, my data file had headers, no age, weight, height. So it had a header. So this has to be specified that the file I am loading has a header. Okay, if you give it false, it will just tell you what, that it has no header. That means it will. So when you give header as true, the first row, it will not consider it as data. It will consider it as a header. Then the third parameter is what? SCP. It is called a separator. If you had seen the text file, the data was separated using tabs. Okay. So this \t basically it says that how the data is separated using a tab. And the last factor is important, which says that any data that is strings, it should be considered as factors. Remember, we had a problem when we were summarizing data, text data. It cannot summarize it. So we have to convert it to factors. So here we have done it together. We have said that whenever you come across data that is of type string, consider them as factors. Okay. So that is why string as factors, we have given it as true. Is that clear how you load? Because this command is important. Again, some response will be appreciated that you have understood this piece of code, that how to load a text file for analysis. So we have seen two things. One is that a standard Excel file, how you convert to a text file. And second is what? How you load it. Is this part clear? Okay, there's a question, when there is no header, that header will be equal to false. So it will, R will give its own header, that means that time. Okay, it will give you something. But again, when you have a data set, see to it that you have a header, because that will make your data more readable. Okay. And basically, you should always give header as true. Your data file should have a header. That means that is, if the header is not there, maybe you can have some problems in understanding the output. So if you have a header, you will easily understand the output. I hope that answers your question. When there is no header, you can give it as false. So then header equal to false, but do not do it. Your data file or your data should have header. Okay, so we now go back to R and okay, so R studio, we go back. Okay, so I'm again clearing. So what was the command in R studio for clearing my console? Can someone quickly tell it if you remember? I want to clear my console here. I want to have a blank, all white. What will I use? Shortcut. Control L. Control L. Okay, so it clears my console. Okay, so I have to now what? Use that command. What is the command? So I have to first create a data frame. So I'm just saying sample data. So where is my sample data? It is in a file and I'm loading it. So what was the command? Read dot table. Then you have to give what? The file path. File equal to what? Path. Where was my file located? It was in E drive. Okay, it was in E drive. Okay, so use a forward slash. You can also use a backward slash, but if you use a backward slash, you have to use 2 backward slashes. So it was in my E drive within a folder. And what was the file name? Test underscore data dot txt. Okay, so wherever your file is, you show the path and give the file name. That is why it was written file path. Then what was there? Header is true. Header is true. Then you have to give a separator. Separator was the tab /t, \t. And then final one, what was we had said? String as factors is equal to what? True. Okay, so this was the command. So this is giving me some, okay, this separator. Okay. Can anybody tell me what mistake I made? You see what mistake I made. You see this S should have been small. You see, again, maybe out of habit, I did that. This S should have been small. But the moment I look at the error, I can quickly understand that what error I've made. This is one to keep on doing it. Okay, so you see it has loaded. It has loaded the table in that data frame called sample data. And now I can display the sample data. So you see, this is my sample data and I display it. You see what we had seen in the data file, text file, it is exactly coming like that. additional is that line number. So ignore this 1, 2, 3 like this. This is just the line number because there are 10 data set. So age, gender, height, weight. Okay. So I've loaded the data file and now I can use the summary function. You see out here. This summary function you already know, but now this summary we will use on the data frame, sample data. And you see this is how the output will look like. So age it is showing, minimum is 33, first quartile, median, mean, third quartile, max. Now remember for gender. So gender it will only show you count data. There are 4 females and 6 males. Okay, and for height and weight, that means age, height and weight, you will, because these are numeric data, it is showing the summary as mean, then your quartiles, mean and maximum. So I hope that means what we have done previously. Now you see our preliminary things. Now we are working on actual data. So I think that learning should be like this. You directly should not be going to analysis directly. That way it will be difficult. First, just try to understand how R is working on small data. If necessary on individual data sets. Then you go to a actual data where it will be in tables so that you now understand what is happening. Is it clear till here? I have 20 more minutes. I can cover some other things also I'll be covering. Is it clear till here? Again, you can tell me or maybe just confirm on the chat box. Okay, some. There's a question, could you show us with example? I think when you are using you say control plus L means you press the control key, do not use plus, just control L. That is what I mean by control plus L. So it is not control key, then the plus key and L key. No, it is just you press the control and L. It is like control copy, no, control C, control V. Paste is control V. So clearing the shortcut is control L, so as to say, but we generally write it as control plus L. So do not get confused about that. Plus it is not required. You just like your copy is control C, clean, that means clearing your console is control L, as simple as that. So I hope that clears. Okay, there are some other questions, so we will get those things also that you are asking now, that I need that, all those things. Remember summary, when you use the summary function, it will only show you what is listed in that function. So it will show you this mean, max, the quartiles and your mean. Okay, if you now want those on, we'll see to that. Now say I want the standard deviation. I have this data. Okay, so I can, there are all these things can be done, but not with the summary function. Say I want to find the standard deviation of the age. Remember, I'm not going to the advanced directly. The thing is that I want to find the standard deviation of age. How do I do that? So the function is SD, standard deviation. And where is my data? It is in sample data because I've already loaded into sample data. Okay, sample data I've already loaded, but I am only now interested in which factor, only the age. So I have to specify it. And this is specified using this dollar symbol. So what will I write? As the sample data dollar age. Is Manjisa, could you follow? Because you had asked that question, I think. It's not exactly your answer, but it's on that line. Okay. So, but remember here again, this age, this factor you have typed here, it has to be like, you can, if you write small a, it will again give an error. I'll show it to you. Let us show it. You see it has shown sample, that means standard deviation for age. It is 8.521867. right? But say again by mistake, I give it a, small a. Remember, it will not work. You see, it is giving me what? Not available. That means that factor it did not find. So be careful about all these things, that how you label the headers. Okay, avoid using spaces, because again, many of us have that habit that headers also we use spaces. It will give you a lot of problems here. Give understandable headers and use a consistent format. For example, all the headers I have given here, I'm starting with capital. Okay, that is the consistency part. Otherwise, again, you'll get confused. You'll maybe because I'm taking a small table. You can take a big table. It can have lot of those factors. And somewhere it is just showing you NA like this. You'll get confused. Okay, what is happening? You have to again open the table, see what is happening, why it is giving you NA. Right? So be careful about how you label your data. That is why I'm saying that data preparation is also a very critical job for data analysis. Data analysis, I would say, comes much later. Okay, so that data entry, validation, data preparation, all these things are very important. So you need not jump to analysis all of a sudden also. Because R will do the analysis part. Okay, it will not do the other things. Remember this. Okay, so that is you need to keep in mind. I hope that is clear. So similarly, I can find the other things also. Okay, I want to find the standard deviation of say what to say, maximum weight. I want to find maximum weight. So I'll write max. So sample data and dollar. I'll write what? Weight. W is capital because my header.
Excuse me, sir.
I've written yes.
So we will end the session at around 4 p.m. So just
Yes. I've kept track of that. I'll do that.
Yeah. Okay, sir. Okay.
Okay. Thank you. So you see, again, if I'm writing small w, it will be a problem. Capital W. Okay. I think I have a problem with my keyboard. Is not coming. Capital is not coming. Okay, fine. It is not showing. Okay, it is capital only. It doesn't show. Okay, so you see it is showing as 72, right? So like this, you can calculate the individual things also, but just keep this in mind. Now there can be some more analysis. That means, okay, say if I go to my slides again, you see I say want to calculate the proportion. Fine, this one proportion. I can find, but proportion again will be on what? Count data. All these things you should keep in mind, that a proportion now will be on count data. That means, yes, on the gender. That what is the percentage of your males and percentage of females. So proportion will not be on age and all those kind of things. That is the understanding thing, that where you use proportion. Okay, there is some time constraint. This is, let me first complete what I had to cover. So this we have already done. Now you see what we have looked at basically are the simple data summaries. So quantiles you have done. You can also look at skewness. Okay, so you know, again, when you talk about skewness, you must know about what is positive skewness, what is negative skewness, what is zero skewness. Now remember, to calculate the skewness, it will not work with, that means the base functions. You have to install some other packages. Okay, but say you do not have access to the, I'm just giving you some what constraint, that I'm telling you that you cannot use the other libraries. You have to only use the base library to find the skewness. How will you do that? So is the question clear again? That yes, there are some other packages which you can install and do skewness, but I am just giving you a restriction that you cannot use it. You have to use the base function to calculate skewness. How will you do that? Again, if anyone wants to respond, if the question is clear. Remember again, when you are programming or doing analyzing, the base case scenario is that you have access to everything, whatever you need. But it need not be the case. You might not have access to certain things sometimes. But with the available resources, can you do it? So that is actually easily possible. Why? Because I know the formula for skewness. Okay, I know the formula for skewness, and I have to just maybe do some additional calculations. So if I'm directly using the skew function, I'll just directly write skewness within bracket, I'll give the data set, it will calculate. But otherwise, if I know the formula, I can still calculate. This means just because you are now doing you are analyzing data using available functions, basic formulas should be known, and how to work with those basic formulas in R again should be very clear. So this one basically it means what? We are just converting this formula into some code. So we are using a function called length to calculate how many values are there, n. And then we are calculating the mean. We are calculating a standard deviation, because here x bar is the mean and s is the standard deviation. In fact, this capital S is the sample standard deviation. Okay, and we can calculate the skewness easily without even using the additional package. Similarly, kurtosis is also a very important summary measure. Okay, so the difference between skewness and kurtosis is what? That skewness basically talks about tails, no? So it is positive, negative, zero. Zero means it is very symmetric. But what does kurtosis tells us? It tells us that even though it's not exactly, remember, peak, it's not about that. It's about a comparison with your normal. You know about the normal curve. Normal curve, if it is normal, that means the distribution of your data closely follows the normal like this. That means the peak is normal. We call it basically what that the it will be a normal mesokurtic. Okay, but if it is too tall, that means with relation to your normal, we'll call it lepto. Okay, they have a sharp peak and heavy tails. That means the tails will be extending long. And then you have the negative, where the curve will be flatter. Fine, and the tails will not be that big, right? So then they are platykurtic. Now you see the values, because you will calculate the skewness value or the kurtosis value. Looking at the value, you can now comment, okay, about the distribution. And because I said while you do kurtosis, it can help you maybe detect the presence of outliers. Remember again at the very beginning, we had told you that outliers can be very dangerous. So even if you had not planned doing kurtosis, this kurtosis measure you can find out and check out if there is an outlier. Okay, that is why maybe you will be doing kurtosis or find this value. So this is again the formula for kurtosis. Fine. Remember again, these are also related to moments. Okay. Second order moment is a third order moment like this. So that is why this n minus 3 is coming, just become S4. So because one comes out of the other like that. Now understanding this formula is again crucial. I repeat that you have to understand the theory very well before you go about the analysis. Now many people think that when you talk about descriptive statistics, it's about this: mean, median, mode, variance, skewness, kurtosis, count, proportion, this much. Okay, but actually when you talk about data summaries, because data summary means what? It's about summarizing your data. So it can mean many other things also, like you see the finding the correlation coefficient. The correlation coefficient is also, when you are finding correlation coefficient, you are summarizing data. Why? Because it helps us to understand what? Whether two variables are related. Say in my data set, for example, a sample data set I've taken, I'd say age and height. So in my data set, is age related to height? So I find a correlation coefficient and I can have a fair idea, because if there is a relation, either it will be positive or negative. And if there is no correlation, it will be 0. So positive means what? Of course, if age goes up, height also goes up. And negative is that if age is going down, height also goes down. But again, as you know, for a realistic age data set or age height data set, till a point, there will be positive correlation. And beyond a point, maybe there will be no correlation. Okay. And you have a basic, you do not need any additional package here. You have a basic function called COR, and this is how you use it. Again, right, there are two data sets. It says that I can find the correlation coefficient with itself. So when you design a function, this is the basic assumption that my two variables need not be different. So they can be same. So that is why Y can be an empty set. But if it is not empty, you do not give null. Use everything means what? That if some data is missing, even that missing data will be used. But if you do not say use everything, there are some other options also, then missing data sets it will ignore. Say for example, the age information is there, height information is not there. So height is missing. But when calculating the correlation coefficient, it will use that missing also, because it uses everything. But if you do not use everything, that entire pair will not be considered. And then because there are many different ways of finding the correlation coefficient. So most popular is the Pearson's, Carl Pearson's correlation coefficient. So you can give the method. There are others also like Spearman's. Okay. So if you give the method, it will calculate that particular correlation coefficient. So similarly, you have index numbers also. You can, index numbers are also a summary, because they are used to summarize and show the relative change in a group of related variables. Now you have the Sensex. So basically, I look at the Sensex value daily. I know how the market is doing. If it is going up, it is positive from day before, I know it is doing well, because but ultimately it's a summarized value. So we have a wholesale price index, we have a consumer price index. These are all summarized values. Okay. So this is data summary only, or data summaries, as you can as you want to tell it. Okay. So my time is more or less up. Fine. So these are some of the resources you can use. One is on data science and the other is on introduction to R. So remember, if you want to be good at data science, both has to be taken parallelly. You need to be good at data science. That means you will understand the concept of data science, statistics primarily, visualizations. And if you are using a tool for that, in this case, if it is R, so it's not necessary that you need to only use R. You can use other tools also. Okay. So even for many things, even you can use even Excel. Excel is also very powerful. Now for visualization, you have an add-on called Power BI. Okay. You can use Python, you can use R, but R has its own strength. Okay. R has a, that means, for example, I told about index numbers. So there is a library for package for calculating those indexes also. So because it is open source, there are a lot of developers all the time working on that. There are a lot of helps available, and it can work with large data sets, very large data sets. There's a lot of flexibility. That is why R is very popular. Okay, that is R is very popular. In fact, nowadays even other softwares are also, or packages are also providing support for R and Python. So with this, I come to the end of my presentation. Okay, so we'll be happy to have your feedback and provide you with assistance in your R journey. I'll be available. It's not that it's only these 2 hours. So if I can be of any help, you can always mail me, or that means I shall try to help. Okay, and I'm grateful for your patient hearing. Maybe I have expected some more conversations. Anyway, I think that happens always, especially in an online thing. And I thank you. I thank the organizers for giving me this opportunity. So this is the first time I am working or giving a lecture in a workshop organized by Royal Global. So thank you for the opportunity. I also thank all the participants again. So if you have anything, you can always get in touch with me. I'll try to help. Okay. If you have any problem, or if you find some problem in analyzing your data, of course, I'm not guaranteeing that I'll be able to do it, but definitely I can provide you with some help. That is sure. Thank you. Thank you so much.
Thank you, sir, for the wonderful session. And on behalf of Royal Global University, I welcome you to our campus for a session over here at our campus. This is a workshop online, but I welcome you to our campus for such wonderful sessions again, with maybe students as well as faculty members who are interested in this journey of R. So with this, I would like to conclude the session, the 4th session for today. Tomorrow again, we will be meeting for the 3rd day, and the sessions again will start from 11 a.m. onwards. Thank you, sir, once
Thank you so
again.
much again. Thank you.
Thank you,
Maybe
everyone.
I'll be joining some of your sessions. Because I think you have some very good resource persons out there.
Yes, sir. Yes,
okay,
sir.
I'll be definitely joining
Yes,
some
sir.
of the other
Most
sessions
definitely,
also.
sir. Most welcome.
Thank you so much.
Thank you, sir. Dear participants, thank you all once again for being with us for the 2nd day of the session, a workshop. And tomorrow we will meet again at 11 a.m. Sharp. Thank you all.